Welcome to Mr. Capreto's lesson on simple interest. We're going to talk about percents, decimals, tax, and depreciation. So the first thing we need to do is be able to convert from decimals to percents. They are really the same thing, only they are represented in different forms. It's almost like saying 12 inches is the same thing as 1 foot. It's the same distance, it's just represented two different ways. So first let's look at these decimals. We'll look at 0.45. The rule for converting a decimal to a percent is to move the decimal 2 places to the right. So 0.45, the decimal now is to the right of the 5, so this is 45%. We have three numbers here. Rule still applies just the same. Move the decimal 2 to the right, 76. There's our decimal, 0.5%. Could throw students off. We have one number, but when we move the decimal 2 to the right, that's 7%. Certainly we do not need to put a 0 to the left of the 7. Unnecessary. Another tricky problem for students at times, when there's only one number. When we move it to the right once, you need to move it to the right again, but there's no number there. Well, we'll tack on a 0. So this is 40%. Okay, we have a number bigger than 1. Well, that is allowed. We move the decimal 2 places to the right, and we have 125%. Clearly my computer is being a little slow, that's why we're getting some of these lines that look too straight and not curved. We can go the other way around. We can convert percents to decimals. Well, we're just undoing what we did. So instead of moving the decimal to the right, we're now moving it to the left. So in this case, the decimal right now is to the right of the 5. So we're moving left 2. So this as a decimal is 0.75. Again, similar example, decimal 2 to the left, 0.32. Here, similar example to one of the ones in the last page, when we move it once to the right, we run out of numbers, but we still have to move it a second time, so we have 0.05. Again, this could throw students off. We move it 2 over. There's your decimal. You can simply write 0.4 by itself, but if you add the 0, there's nothing wrong with that. So either way you want to write it. Here we have a number that's bigger than 100%. Again, we move it 2 places to the left, so we have 1.137, and it's okay to have a number, bigger than 1 as your answer. Alright, some key terms that we're going to throw around in these problems. The original amount of money that is borrowed or invested is known as the principal, and this is the same spelling as the principal of a school. It's the principal amount of money, the initial amount, the money that is borrowed, invested, what have you. How fast the investment grows is determined by something called the interest rate. As going through the problems, sometimes you will hear it just referred to as the rate, or just referred to as interest. Interest rate, all of these are going to be generally referred to the same thing, the rate at which the money is growing. Alright, so let's get to an example. David buys a book for $32 at checkout. The cashier adds 7% sales tax. How much money does David owe? Alright, well, to do these problems, first we're going to convert our percent into a decimal. So that is 0.07, as we learned before. Well, to find the tax for anything, we go ahead and we multiply it by the initial value, the principal. So 0.07 times 32 gives us 2.24. Now, is that how much he owes for the book? No. That would be wonderful, not so fortunate. That's how much tax is added on. So what we still need to take is $32 that the book originally cost and add that on, so now we have $34.24. So percent as a decimal times the initial principal gives us the tax that's added on to the original, giving us our final price. Well, there is a shortcut. Instead of doing that in 2 steps, multiplying and adding, we can do it in 1 step. If we realize that 7% is added to the initial is 100%. So 7% plus the initial 100% is 107%. As a decimal, 1.07. We can take that and multiply it directly by our 32. And when we do that, straight out of your calculator, 32.24. Calculator obviously not necessary, but for these problems, I would consider it just fine for you to use a calculator. $32.24 comes out in one step as opposed to two steps. Okay, now we're going to look at the reverse side of the coin, depreciating value, or any situation where we're losing value. The final answer is going to be less than the original. So we have 4 years ago, Samantha bought a TV for $650. Like all technology, it has depreciated by, in this case, 47%. How much is it worth now? Okay, so $650. Initial value, the principal amount. We're going to multiply that by 47% as a decimal, so 0.47. When we do that, we get $305.50. Is that how much it's worth? Not quite. That's how much value has been lost from the value. So we'll take our 650. We're now going to subtract 305.50 cents. When we do that, we end up with $344.50. That's the final value of the TV after it's depreciated in value. Well, again, there is a shortcut. So, if it's lost 47%, how much is the TV worth in terms of percents? Well, we've gone down 47%. It was originally worth 100%, so now it is worth 53%. 53% as a decimal, 0.53. So again, 100 minus 47 is 53. 53 minus 53 as a decimal is 0.53. So we're going to take that, multiply it now by the 650, and in one step we come up with that same number, $344.50. Terrific. That's all we have so far on calculated simple interest. We'll use some of these problems tomorrow in class.